Assalamualaikum, my name is Shafiq from Group 7. Together with Ashraf and Haris, we will present the experiment measurement of jet forces. Abstract. This experiment was conducted to determine the reaction force generated with the change in momentum by the stroke of the water liquid between the flat plate and the hemispherical surface, and to compare the value of the theoretical force with the value of the experimental force using the momentum equation. The momentum of force was determined from the measurement of the force that is generated when the flowing water hits the surfaces according to Newton's second law of motion, which then deflects the jet at different angles. In this experiment, several aspects are taken into account, which is the measured moment force, the volume of water collected, which is constant at 2 liters, the time required, the flow rate, the speed of the water jet, the theoretical moment force, and the percentage of relative error between both surfaces of a flat plate and a hemispherical plate, where is applied to exert what is believed to be the force of the water hitting the surface. Objective: to compare the force applied by the jet of liquid colliding with the flat or hemispherical surface with the theoretical value. Introduction. Water turbines are widely used around the world to generate electricity. Mechanical work can occur because pressure fluid hits the blade of a turbine wheel. The rotary motion is then generated by the force that is created when the jet hits the blades. The most common type of water turbine is the Pelton wheel. In this type of water turbine, one or more water jets are directed tangentially onto the blades or rotor blade held on the edge of the turbine disc. The impact of the water on the blades creates a torque on the wheel that rotates it and develops power. To predict the performance of a Pelton wheel and determine its optimal speed of rotation, we understand how the reflection of the jet creates a force in the cubes and how the force is related to the speed of flow in the jet. This experiment aims to evaluate the different forces exerted by the same jet of water on a variety of different geometric plates. This experiment measures the force that a jet of water creates when it hits a deflector.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf Amni bin Matlazi. So today I will present about measurement of jet forces for today I will present for two parts, which is theory and methodology. So for theory, force that was produced when a jet of fluid impinge or what we call crash on the test surface, which is we have two types of surface. The first one is flat, and the second one is hemispherical surface. The force that occurred is due to the change of momentum of fluid, which the equation for momentum is m equal to rho av. So the force that generated by jet water depends on the shape of the test surface. So by applying the energies equation between the nozzle axis point and the surface of deflector, it shows that the magnitude of the flow velocity does not change as the water flow around the deflector or the surface. So next, for the equation, velocity is equal to flow rate, which is Q, divided by cross-sectional area of nozzle. So in this experiment, we will use around 4 unit or 4 sign. The first one is F, which is force. For A is cross-sectional area of nozzle. And then theta is angle. And last one is V, which is velocity. So in this experiment, there's two surface. The first one is flat surface. For the flat surface, the equation for the flat surface is F is equal to rho AV1 squared minus rho AV2 squared cos theta. So theta is 90. So when we use calculator, we will get V1 is equal to 0. Therefore, for this equation, we get F is equal to rho AV squared. Next, for the hemispherical surface, the equation is F is equal to rho AV1 squared minus rho AV2 cos theta. For theta is 180 degree. Therefore, we'll get cos is equal to 1. Thus, V2 is equal to V1. So, in this equation, in this type of surface, which is hemispherical, the equation is F is equal to 2 rho AV squared. Next, for the methodology, this is apparatus that we use in our experiment. So, for the methodology, the first one is we have to determine two type of deflector or two type surface, which is flat or hemispherical. Next, we have to remove cover and the level mechanism. Third, we have to put assemble the test deflector, which is for the first one, the first reading we use flat plate. Next, we have to put back the cover, which we already put the flat plate, and then to the level mechanism into the tank. Then we have to tighten the cover, which we have to screw by 3 screws. And then next, we have to make sure that the pointer is show at the 0 notch by adjusting at the screw level mechanism. Next, we have to turn on the main switch and the pump. Then we have to open slowly the flow control valve until it become maximum flow. Next, we have to when we already open the flow control valve, we can put that our desired brake, which is maybe we can put 10 Newton or 20 Newton until it reach 0 notch. So when it reaches 0 notch, we have to close the sliding valve, and then after we close the sliding valve, we have to determine Q, which is flow rate, by recording time required to fill up 3 liter of volume of water in the volumetric measuring tank. And then so for the second reading, we have to reduce the weight that we put at the first reading, and then adjust the flow valve. And then we have to make sure that when we reduce the desired weight, we have to make sure the weight at the indicator that shows it reaches 0 notch, so that we can determine the Q, which is flow rate by recording T required to fill up 3 liter volume. So after that, this is after we determine Q for when we reduce the desired weight, we have to repeat the experiment, which is we have to use hemispherical surface by doing the same procedure until by using the appropriate load weight until we get determine the Q and T for the hemispherical surface. I think that's all for me. Thank you.
Assalamualaikum and good morning. My name is Haris Imran Mehrul Hisham. So today I want to present my part, which is results, discussion and also conclusion for experiment 5. So for the results, so this is the result for flat plate. So as you can see, this is the measured force. It is already given, and this is the volume of water collected in liter. It's constant 2 liter, and the time is given. And for the flow rate QX, we can calculate by volume divided by time, so we can get it. And for velocity, as we know, V equal to QA. So A is 10 millimeter, so we can calculate V. So this is theoretical force, we can calculate by F TH equal to rho A V squared. So this is percentage of relative error that we get. So for the second table for hemispherical surface also same, but the theoretical force, the equation is 2 rho A V squared. So for the discussion, so for first question, plot a graph of log FMEA versus log V for both the flat plate and hemispherical surface on the same graph. So so we already plot. So this is the linear graph. So next, estimate the slope of the graph for both the flat plate and hemispherical surface and compare with the theoretical value as shown in equation 2 and equation 4 respectively. Comment on the difference. So the slope of the graph for flat plate and hemispherical surface is a linear graph. So by logging both sides of the theoretical equation, we are able to get, so for a flat plate we get 2 log V1 plus A. For hemispherical surface also we get 2 log V1 plus A. So the equation above is similar to the equation of the y equal to mx plus c, where m is the gradient. So thus the graph obtained is correct. As we can see, as we know the previous slide, we get the linear graph, so it's correct. So based on this equation, we get for flat plate the gradient is 1.813, while for hemispherical surface is 1.687. So the difference between the value from slope in graph and theoretical force for both plate. So this might happen because due to the bubbles present in the water that can cause inaccurate readings. So B, estimate the y-intercept ratio of hemispherical surface to flat plate and compare with the theoretical ratio as deduced from equation 2 and equation 4. Comment on the difference. So for flat plate, as we substitute into the equation, we go to mx plus c, we get c equal to negative 0.9926. Also same with y-intercept 0.9926. So for hemispherical surface, we substitute in this equation, we get c equal to negative 0.5636. And yes, that the y-intercept. So the theoretical ratio is 0.5438, while the y-intercept ratio is 0.5403. So there are very minor difference between theoretical ratio and y-intercept ratio. So C, compare the force exerted on the hemispherical surface with the one on the flat plate. Which one is greater? Why? So from the experiment, we can see that the force exert on hemispherical surface plate is higher due to the momentum produced, which is higher than flat plate. So the force exerted on hemispherical plate is greater than flat plate because it lies on the behavior of water jet when it strikes the flat surface. It forms a radial sheet which impinges on the inner wall of the surrounding cylinder and then divide some of the water flowing down the cylinder wall and the rest flowing upwards. Although visibility is impaired by the spray which is generated, it does seem that some water falls on the top side of the vane. This will have the effect of producing a small momentum force in the downwards direction, so reducing the net upwards force on the vane. Next, question number 2. Compare the percentage of relative error for both the flat plate and hemispherical surface as function of jet velocity. Comment on the analysis and explain your reason. So based on our data, the percentage of relative error for both plates are different, which is for flat plate is 20.09%, while for hemispherical surface is 2.14%. So from this experiment, we can say that the percentage of relative error for both plates are from high goes to low and going back higher. So the shape of the plates, one of the reasons why the error are different, and also the shape of spring coil will cause the error. So question number 3. Briefly discuss on factors contributing to errors or inaccuracy in experimental data and possible recommendation to improve the existing results. So for the first error, parallax error due to position of ice which is not perpendicular to the scale of measurement. So, second, control valve may not be fully open, which will affect the result. Third, errors in calculating due to uncertainty in measurement. So for the recommendation, first, the position of ice must perpendicular to scale. Second, ensure that control valve fully open before adding weights. And last one is repeat the experiment at least 2 or 3 times for each readings to get the average and accurate results. And fourth question, suggest 2 application of jet impact in industry. First, generate electricity. Jet impact is used to rotate the turbine, which is Pelton wheel in generator. The water jet applies force tangential to the wheel. The tangential forces of water jet generate moments to its maximum value. Therefore, it will increase the mechanical energy of Pelton wheel and the rotational energy of wheel then converted into electrical energy. Second, water jet cutter. Water jet cutter is capable to slice metal by using high pressure and velocity of water. So lastly, for the conclusion, so in this experiment, we can conclude that the force exerted on the hemispherical plate is greater than flat plate. That's all from me. Thank you.